right? That swarm of bees, imagine if those things actually had, like, they were going in circles, right? That's what an elliptical galaxy would be. There's no plane in which you could see them, right? They're not like spiral galaxies like that. They're just, and basically, elliptical galaxies are a more chaotic state. It's like your room after you haven't cleaned it for a while, right? There's normal spiral galaxies. These things look like cow pies, and then this is like very defined spiral arms like this. The difference between this guy and this guy is that if we saw this guy on edge, it would look like this. Be like, right? Whereas elliptical galaxies are really like this. Doesn't matter how you see them, they're always going to be elliptical, yeah? They're more chaotic. Is that right? Am I telling them a lie? I don't think so. Stop me, if I ever... What did I do? I did this. Hello, test. There we go. All right. And then there are barred spirals. Barred spirals have this little bar like that. But if you hold on, there's a really, really good way to identify barred spirals. Because some of the barred spirals look like normal spirals, right? So I'm going to show you in a sec. I'm going to show you a slide where there's a really, really good way to tell the difference between the two. And then I like this. Hubble came up with irregular and peculiar. And can't you see a couple academics sitting there talking to each other? Well, would you say that's irregular? Or is that peculiar, Edwin? Right? Oh, I'd say it's more peculiar. Right? Okay, I don't know. Are you picturing this? I'm kind of picturing that, right?
I think irregular.
So this is if this is a galaxy on edge, which it is, okay, it bulges in the middle 16,000 light years thick, but out by us it's just 3,000 light years wide. So this is 3,000 light years, right? Okay, and we are out here about 30,000 light years from galactic central point, right? So the Milky Way is 100,000 in diameter. This is 100,000. This is 50,000. We are 30,000 from the center, so I just put an arrow where I thought 30 would be. I didn't measure it, but that's about it, right, isn't it? Yeah, we're kind of there-ish. So we're more toward the edge than toward the middle, kind of a thing.
So the speed of light
it would take 100,000 years for light to go from one side of the galaxy to the other side. That's what 100,000 light years means, right? Which, while we're talking about that, what that means then, if you see something that's 100,000 light years away, or if you see Proxima Centauri that's 4.3 light years away, right? Or one of the Abuteru Alpha or whatever it is, right? You're not seeing it now, right? You're seeing it as it was 4.3 years ago, correct? Right? So when you look at the Andromeda galaxy, which is like, what, 2 million light years away? Right? You're seeing it as it was 2 million years ago. So big telescopes are actually time machines, right? They let you see faint light from distant galaxies, and you're not seeing it as they are now. You're seeing it as it was millions of years ago, which is kind of a cool thing, right? I know. It's like
we don't know it yet.
Kids' eyes, right? So the sun, aren't we like 8 light minutes from the sun or something like that, right? So we're not seeing the sun as it is now. We're seeing it as it was 8 minutes ago, which is isn't that weird? Sometimes kids, just their eyes get bigger and bigger in this unit. It's like, at some point, no, I don't believe that, So this is a crazy thing. 100,000 light years wide. There's about 100 billion stars. They have a more accurate figure than this, but it's on the order of 100 billion stars. Put this in your snipe and poke it. In the part of the universe we can see, there's about 100 billion galaxies, each with about 100 billion stars. Yeah? That's a lot of stars, isn't it? It's like 100 billion, 100 billions, right? And then, here's a weird thing, is that the part of the universe that we can see is a relatively small part of it, right? We're cut off from a lot of the universe, and the part we can see, we think, is the size of a proton compared to the size of the Earth, is the entire universe, right? So, but God still loves you, so don't worry about that. Okay. The total mass of this thing is about 3 times 10 to the 41st kilograms. And what's interesting is if you divide this by this, don't you get 3 times 10 to the 30th per star? Which is about, our star is about 2 times 10 to the 30th kilograms. So our star is it's not the biggest star. It's a little bit smaller than average, but that's because there are some giant stars out there, right? 28,000, they said 30 in the song. We'll forgive them, right? It's not a real huge galaxy as far as galaxies go, right? Here is, kids always ask what this structure is here that's going across the Milky Way like that. That's where the Milky Way, they believe, previously was actually folded. and folded and placed inside a National Geographic. They probably have this image. I could just like go to their website and probably find this. This is their, I got their map there, you know. But here we are out here in our little spiral arm, you know.
Check it out. This is why I came in. Have you actually done the zoom in part?
Yeah, we gotta see this. Okay, watch
gotta
this.
see it.
Duggan sent me this thing,
Unbelievable.
and I put it on the links. Did
You're
I?
the first Tualatin kids to ever see this thing.
Did I update it though after I put it on the links?
I don't know.
No, I didn't. Okay, what's it? What's this? It is.
Skyscape. It's Skyscape.
Nope.
Skyscape. Put 30,000 images too. Maybe that'll get. Yeah, there you go.
What is it?
Oh, there you go. Sky telescope. 5,000 megapixels of sky.
Where is it?
Like 5 down.
This one?
No. One more. One more. There we go.
Where's the link to it? Interactive Sky right here. No. Part of the site. Damn it.
Okay.
Hold on.
You get from email.
Yep. That's what I'm going to do.
This is unbelievable. When you zoom in.
I put the link out. I didn't update that. Okay, where did I put it? Oh, come on. I think I put it in physics, didn't I?
Now you have to find it because you're going up further.
I know. It's my fault. Hey, you could go and send. Yeah, the link's going to be there. There you go. Down there. Skysurvey.org. Yeah. Sweet.
Check this out. Okay, so here's zoom in, right? You can click on this and it loads this cool Java app. Right? You can make it like full screen, right? And then you can zoom in. Like, yeah, let's look at this part.
It's like Google World. Oh my God. Yeah. And then it just Google World. You can even go more. Go more. Is that as zoomed in as it'll go?
Hold on.
Whoa.
Nick?
Here you can see Cybertron where the angles are.
Now it's all zoomed in, right?
But you can see, like, some of those stars are bluish looking, and some of them are reddish looking.
What does this do?
I don't know.
Zooms out. Okay, let's
You can
escape.
just like go back and forth, and you can see any part of the Milky Way.
Go back. And then this thing, I like this thing. Did you check this one out?
No, I didn't.
So here's a picture of it, and then you can go around and around, right? So it's basically just the night sky, and you can go, let's look away from the Milky Way, right? All right, let's go back.
So you guys know, like when you're camping,
Now watch
you
this.
see the band of the Milky Way. And look, it's the Milky Way. That'd be kind of like saying, "Hey, look at the classroom. You know, you're sitting right in the middle of it." That's the same.
Yeah, so when you are sitting in the Milky Way, where's the Milky Way? Isn't this it right here? The band across the sky, right? Okay. So there it is. Locally, if you look, there's some clouds here. So there's a bright band. These are the stars. There's also clouds of dust that you can see, right? So now we're just looking around from our point of view, obviously. Here we must be looking away from the galactic central core, right? Because it's really relatively thin, right? Nope, I can't go farther. No, I can go farther, right? This is away from it, and then we keep turning. Now we must be looking more. This must be looking more toward the center, right? Yeah? That's kind of cool. And then you can like,
Way cool.
and you can make this,
I see.
I know. I see booty.
Booties. Booties. Arcturus. Hercules.
Leave it up to high school boys to.
So anyway, thought I'd show that to you. You want?
Yeah, turn on the.
Lights?
Yeah, sure. This is So here's an elliptical